everybody. It's a pleasure to be here. San Diego is one of my favorite places. I actually spent 6 months here a couple of years ago. So in true University of Chicago fashion, I am happy to be interrupted. So at some point, you know, if you have questions of any sort, if they're really long questions, we may postpone them to the end, but feel free to ask. I'd rather know what you're thinking and where you are while I'm doing it than at the end. Okay, so I'm going to tell you today about how our hands help us think. And what I want to do is begin with a videotape. So this is a guy, a regular guy, asked to talk about a moral dilemma. And he started talking about the dilemma, and his speech is a little convoluted. He's a U of C grad, too. His speech is a little convoluted, but his gestures are really clear. What he does with his hands is he holds up his hands and he said there are 2 points of view, and they come into competition. And then he starts saying, but that's the moment when you find negotiation. And you can see his ideas just laid out in his hands. So take a look. In the sound is off.
And when I think about opportunities like this where you have 2 interests that compete with one another, this is the point where people develop the skills of negotiation. Even with my young son.
Okay, so complex ideas can be conveyed in gesture. But we can also convey ideas that are much more simple. And we all know that whenever we talk about space, it's really hard to talk about space without your hands going up. So this is a woman who was just asked to say how you get from one location to another. And watch her.
But not least, how about from home to Ashton?
Okay, well, Ashton, we go left and then out to 3rd, and then up to Jordan, then right again, and we go straight up to 10th Street, but we turn right on 10th. So Jordan is actually, which would be like right here, it's behind us instead of crossing into the library. Mm-hmm. So we go right, and then we cross a driveway, which is to right quad, and then cross a street called Sunrise, and then Ashton is we keep going a little bit further, and Ashton, you turn right to get to Ashton.
Okay, good.
So there's nothing special about her gestures, nothing special at all. But there actually is something special about her, as some of you may have noticed, because the dog starts wiggling in the middle of this. She's blind. And she has been blind from birth. She's congenitally blind. So if you think about that, that's sort of interesting. How did she learn to gesture? She's never seen anybody gesture. And yet, she moves her hands spontaneously when she talks, which just suggests that gesture is a really robust and integral part of speaking. So the question I want to talk about today is whether gesture is more than hand waving. I mean, it looks like we do all of this stuff. So is it substantive? Does it tell us anything? And obviously the answer to this question is yes, or this would be a really short talk. So good, we're starting with a yes. So, and what I want to suggest is that gesture is a window onto our thoughts. And importantly for me, sometimes that window shows us things that we don't hear. So you can find out something special by watching through this window that gesture gives us. So first what I'm going to do is try to convince you that gesture can reflect what we know. Okay? But in fact, I want to spend most of the time trying to, since gesture reflects what we know, it means that it can be a really useful tool for researchers like me, but it actually can be a really useful tool for parents, clinicians, teachers, for anybody who's watching gesture. And therefore, it can sort of convey information to us. So that's the first part that I want to do. But I want to suggest, actually, that gesture has the potential to do much more. That gesture not only reflects what we know, but it can actually change what we know. It can change our minds. And I think it has the potential to change our minds in 2 different ways. And I'm going to explore both of them. The gestures we see others produce can change our minds. And the gestures that we ourselves produce can change our minds. So I'm really suggesting that by moving my hands in a particular way, I'm not just telling you what I know, I'm changing what I know. So we'll see if I can convince you of that. Okay, so I'm going to do that second, and then look at the gestures that we see can change our minds, gestures we produce, and then finally we'll spend some time talking about the how. How does gesture work? And we really, really don't know the answer to that question, but I'll give you some thoughts that we have about how gesture works to change our minds. Okay, so let's start. Gesture reflects what we know. Here is a phenomenon. Actually, I discovered this. I learned about this for the first time when I was in Geneva at the Piagetian Institute. This is Piaget discovered this about children. What he does is he shows children 2 rows of checkers. And he establishes that the child knows there's the same number of checkers in this row and in this row. Okay. Then he spreads one out. And he asks, is there the same number of checkers in this row as in this row? We all know, of course, there's the same number of checkers. But children below the age of 7 or 8, they say no. They're non-conservers. They don't think the number is the same. So that's Piaget's phenomenon. What I was interested in is the fact that when you ask them why, they move their hands all the time. It's really hard to actually answer that question without gesturing. So here's a kid who was asked, are they the same or different? And she said, different. Why are they different? They're different because you spreaded them out. And she says spread, and she gestures spread.
Like this. Do these 2 rows of checkers have the same number of checkers? No. Which row has more checkers in it? Now, why does that have more checkers in it?
You spread them apart and this one stay like you put them down.
Okay? She's produced what we've come to call a gesture-speech match in the following sense. She talks about spreading out, and she gestures about spreading out. Okay. I want to contrast her with this next kid. He thinks they're different. No surprises there. He says they're different. And he says pretty much the same thing. I think they're different because you moved them. But watch his hands. What he does is he does this. That's not how anybody moved anything. That's really showing the alignment between this row of checkers and that row of checkers. And that's the first step to understanding that there's the same number in this row and in that row. Okay, so here he goes.
Do our rows have the same number of checkers in them now or different numbers? Why is there a different number in all those?
Because you moved them.
Okay.
Okay, so he's produced what we've been calling a gesture-speech mismatch in the sense that he says, because you move them, but he gestures about one-to-one correspondence. There's different information, not necessarily contradictory, different information in your speech and in your gesture. Okay, so we discovered kids like these mismatchers and thought, well, maybe they know something different about this task than kids who are matchers. So in order to find out, what we did is we took all of these kids, none of whom understood conservation, as this is called, and we gave them all instruction in conservation. And then we looked to see how many profited, how many got better, how many profited from the instruction. Okay, and this is a graph of those data. So what you see here is the proportion of kids who improved after instruction. So they got their answers, got better answers. The kids in blue are the kids who were mismatchers before instruction. The kids in white were matchers before instruction. And you see that the kids who were mismatchers are ready to learn conservation. Not ready to learn everything, just ready to learn conservation. More ready than the kids who are matchers. So we're able to predict, actually, who's going to take this instruction, who's going to pick it up. Okay, so is this true just of, yes?
How do you define improving?
In this case, there are several ways to do it, but basically in this particular case what we did was the number of conservation responses that you gave that were correct, where you said it was the same instead of saying that it was different. And you also had to give a good explanation. So it depends on the task, but in conservation that's what we did. Thanks. Okay, so we wanted to see whether this is true only of 5 to 8-year-olds, only conservation, or is this a general phenomenon? Just how much is this about conservation and children? So we used a math task. Now, this particular math problem turns out to be really hard for 4th graders in America. It's a little depressing, but 4th graders in America can't solve this problem. By 5th grade they can, so it's not that depressing, but still, 4th grade. Okay, so what they do when they fail to solve this problem is they do one of two things. They either add up all the numbers in the equal sign, and they put that number in the blank. For those of you who are teachers, you know this. Or they add up all of the numbers on this side of the problem, and they put that number in the blank. Okay, and we all know, of course, that this is the right answer. You're just supposed to have 3 and 4 in there. All right, so again, what I'm going to do is I'm going to show you a videotape here of a child who is, and this particular kid added up the numbers on the left side of the problem and put that number in the blank. And she says that in both her hands and in her mouth. She says, I pointed at the 5, the 4, and the 3.
And how did you get 12 as your answer? I did 5 plus 4 plus 3.
Okay, she pointed at 5, 4, 3. She produced a gesture-speech match, talking about adding up numbers to the equal sign in both speech and gesture. This one is a little different. She actually is a different kid. She looks exactly the same, but she's a different kid. And she says exactly the same thing. I added the 5 and the 4 and the 3, but watch her carefully, because what she does first is she points at this 5, and then the other 5, and then the 4 and the 3. So she points at all of the numbers. She only talks about the 5.
So how did you get 12? I added 5.
See her?
And then the 4 and then the 3 too.
Okay. So she actually has produced a mismatch in the sense that she's talking about adding up the numbers to the equal sign, but she's gesturing about adding up all of the numbers, that other strategy. So again, we took kids who didn't know how to solve the problem. They all got 0 on the pretest, and on the post-test, they had to get 3 out of 4, or I think over 4 correct in order to be counted an improver. So this is the proportion of children who improved on the post-test. These are the kids who are mismatchers. These are the kids who are matchers. So this isn't just about conservers or conservation. It extends to mathematical problems as well. In fact, I think this is a general phenomenon, and although I won't talk much about adults, I think it's true of us as well. And we're doing some work on organic chemistry showing that the same phenomenon is there. So we also can be mismatchers if we're on the cusp of learning something. Okay, so what I hope this convinces you of is that gesture conveys substantive information about a speaker's thoughts. It's because the kids in both situations are, both matchers and mismatchers are gesturing. It's not just gesture versus not. It's the kind of gesture that you produce, and in particular, the relationship it has to speech. Okay? And importantly for me, I think it's really interesting that some of the thoughts that are expressed in gesture are just different from the thoughts that are expressed in speech. So you actually get a different sense of what the child knows by opening your eyes and looking at the kid than if you just listen to the kid. Okay, so now, can gesture change our minds? So let's go on to part 2. So in order to see whether gesture can really change our minds in these 2 ways, whether the gestures we see can change our minds first, what we need to do is to manipulate gesture. We've got to do something. Give the children one kind of gesture or no gesture, or just manipulate them, and then see what effect that has on children, or on their learning. And so that's what I'm going to do here. So what we did was we took groups of children, and we either gave them the math problem, we gave them instruction in the math problem, and either we had no gesture, matching gesture, or mismatching gesture. And I'll give you examples of this in a minute, but I just want to lay out the structure first. And we gave them one strategy in speech. This is what we call an equalizer strategy. I want to make one side of the problem equal to the other side of the problem. That's sort of that's the heart of this. You got to know about the equivalence between the 2 sides in order to get it. Okay, so they got the equalizer strategy just in speech, they got it in speech and gesture, or they got it in speech with a different strategy in gesture. This add-subtract strategy, and I'll tell you what that is in a minute. I'll give you a good example. But the thing that's interesting here is if you notice the difference between matching and mismatching gesture is that this situation actually has more information. It has 2 different strategies in it. So if we find a difference, we don't know whether it's about matching or mismatching. It could just be about the amount of information. So we wanted to control for that. So we then had another set of groups who had 2 strategies in speech. So this group got equalizer in speech, add, subtract in speech. So it's the same information. This is within modality. This is across modalities. And then to make it neat, we just filled out the paradigm and had equal numbers of kids in each group. Okay, so now let me show you what I'm talking about, since this is all pretty abstract. Okay, so here is Melissa Singer, whose dissertation this was, being the teacher for this child. And what she does is she gives the child instruction just in speech using the equalizer strategy. I want to make one side equal to the other side.
We solve this by adding 7 plus 8 plus 5, which equals 20. And then we want to make the other side of the equal sign the same amount. So 15 plus 5 also equals 20. So 15 would be the answer. So now I want you to try solving it.
Okay, so here is Melissa giving exactly the same speech. She was very, very good at doing the same thing in each condition. But now she does a gesture. And the gesture she does is to make one side equal to the other side. That gesture is one that we see the kids do whenever they talk about equalizer. So we got that gesture from them. We didn't make it up. One side equal to the other side.
That is, we can add 6 plus 8 plus 4, which equals 18. And then we want to make the other side of the equal sign the same amount. So 6 plus 12 also equals 18. So 12 would be the answer. So now I want you to try solving it.
12. Okay, and here's our last condition. This is the tricky one. So she says equalizer in speech, and she does add, subtract. So the add subtract strategy, what the kids do is they add up the 7, the 8, and the 5, and then they take away the other 5. Okay, so that's another way to strategy. It sort of seems a little cumbersome, but the kids actually like that strategy. So, and that's what she does in gesture. Bunk, 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 take away in the other 5. So that's add up and subtract.
Another way we can solve this. And that is, we can add 7 plus 8 plus 5, which equals 20. And then we want to make the other side of the equal sign the same amount. So 15 plus 5 also equals 20. So 15 would be the answer.
Okay, so that's the instruction they got. We had about 20 kids in each group, and this took Melissa a really long time to run. And now what I'm going to do is show you what happened. So first, this is the number correct on the post-test. They had 0 correct to begin with. We didn't let them in the study if they knew anything at all. So we threw them out if they knew something. So these are kids who started off absolutely incorrect. These are the kids who got 1 strategy in speech, and these are the kids who got 2 strategies in speech. This actually surprised us. Because as educators, you know, we think, okay, give them 2 strategies. Give the group one way and another way, and if they don't understand this one, maybe they'll understand this one, so it really sort of maximizes things. Turns out, on this problem, that's not a good strategy. Because if you give them these 2 strategies in speech, it blows them out of the water. It's too hard. So in this case, 1 strategy in speech is far better. Okay, so now what I'm going to do is just split those data into 2 and show you what gesture does. So here again, not a surprise, 1 strategy in speech is better than 2 strategies in speech. But interestingly, this was a surprise. We did not expect this. Mismatching gesture was more effective than matching gesture, which was more effective than no gesture. We actually expected matching gesture to be better because it matches. But mismatching gesture was better. And notice that it's not just the amount of information, because the information conveyed in this big red bar is conveyed here in all 3 conditions here. So I said, you know, can't give 2 strategies. That's not quite right. You can't give 2 strategies in speech. That's too hard for the kids. But if you give 2 strategies, 1 in speech and 1 in gesture, not only is it good, but it looks like it's terrific. It's the best instruction that we have. So that was a little bit surprising to us. 2 different pieces of information, 1 in gesture, 1 in speech, was really effective. Okay. Now, I've been sort of suggesting here that gesture is really good for learning. And that's not exactly what I want to suggest. I want to suggest that gesture is powerful as a learning device. It can be used for good, as we did in our studies, but it can also be used for evil. Because it's powerful. So I'm going to show you an example where it was inadvertently used for evil. The teacher really didn't intend this, but she did sort of mislead the kid. So here's the problem. The child puts 18 in the blank. So basically what he's doing is he's adding up the numbers there and putting in the blank. And she says, okay, well, what you did is you added up these 3 numbers, and she points at the 7, the 6, and the 5 to get your answer, and she points at the other 5. So in fact, what she did with her gestures is she did an add-all strategy. Okay? So, and then she goes on, she gives a pretty incoherent explanation. I have to admit, it's really incoherent. And in the middle of this incoherent explanation, the kid does 23. And if you add up all the numbers, you get 23. So let me show you what this looks like here. It's a little hard to hear, I'm afraid.
Is that what you want me to put here?
Okay, so she puts in 18.
So you get this answer by adding
7,
these 3
6,
numbers.
5, and then the other 5.
Okay.
Just one little gesture. Now the incoherent
But you
explanation.
see, there's like 5 here, right? Do you see? So if we put 13, then we have to add 13 plus 5, and that's more than this. Do you see? Because they have to be equal, right? So 7 plus 6 plus 5 has to be the same as 20. You want me to put 23 here? So 7.
So it's so charming about this example. She doesn't have a clue as to where 23 came from. And maybe it didn't come from her hands, but maybe it did. So, okay. So that works in math problems. I mean, gesture's powerful in math problems. Gesture's powerful in other situations as well. And I want to give you an example of another set of studies that's being done by another one of my students, Sarah Broaders. We all know that the way in which you ask a question can lead the person who's being asked astray. So we can mislead a witness by saying, what color was the hat he was wearing? If you say that, then all of a sudden people start answering with hats, even if the guy wasn't wearing a hat at all. You're not supposed to do that. What you're told is you're supposed to ask open-ended questions. You're supposed to say, what else was he wearing? And then if you get a hat, you can be pretty sure the hat came from him as opposed to you. Okay, so what we did in this study is we first brought in a musician to kids' classrooms, had the kids watch the musician. We videotaped it, so we knew exactly what happened. And then Sarah interviewed the children over a series of weeks about what happened. Okay, so here's an interview. And Sarah's going to ask a very nice open-ended question. What else was he wearing? And all you need to know in listening to him is that the musician was not wearing a hat. Okay.
Okay, what else was he wearing?
A music hat.
A music hat? Was he wearing anything else that you can remember?
Yeah.
Yeah.
A green hat.
A green hat? Oh.
No, queen hat.
A queen hat.
And them cowboy hats, too.
So where did all these hats come from? You already saw her. But what she did was she asked a great open-ended question, but she accompanied
what else
it
was he wearing?
with this gesture. And that little hat gesture was enough to get all of these hats, as many hats as you get, as if you said, what color was the hat he was wearing? It's really powerful, just as powerful as all these guiding questions. So it's actually something that I think is worth thinking about in legal situations, in clinical situations, because we can guide the responses of our people. In a legal situation, it's really bad because gestures don't get written down. In a transcript, you'd never know that that gesture happened. The idea came from the investigator and not from the person. Okay, so now we know the gestures we see can change our minds. Now let's think about the gestures we produce. And again, what we have to do is to manipulate the gestures that learners produce in order to see if that's going to have an impact on how they learn. So what first we did is to sort of establish a control group where we taught them words. We said, okay, I want you to learn these words. I want to make one side equal to the other side, this famous equalizer strategy. And they had to say the words before and after they solved each problem. Okay. This is what it looks like.
I want to make one side equal to the other side.
Okay, now you put your answer in.
Okay. Now, for gesture, another group of kids was taught exactly those same words. I want to make one side equal to the other side. But they had to produce a gesture along with it. And they produced a gesture that we've called the grouping gesture, because if you notice the structure of these problems, because these are equal addends, you can get rid of them, and you can add these two numbers and put the sum in the blank. So they were taught to do this grouping strategy. Here it goes. This is what it looks like.
So first of all, can you say the words and do the hand movements exactly like we practiced?
I want to make one side equal to the other side.
Okay, now can you put your hand?
So she's in a way producing a mismatch. We've taught her to produce a mismatch. She's saying equalizer, but she's gesturing, grouping. Okay. And then to control for the fact that there was, one group is moving and another group is not, we decided to teach a second group a gesture, but a sort of partially correct gesture, partially incorrect too. So instead of having them point at the 4 and the 5, we had them point at the wrong numbers, the 5 and the 7, and then point at the blank. So do this. Now, we called it partially correct because initially I thought this was going to be really, really terrible because they're pointing at the wrong numbers. I mean, how's that going to help? But it is sort of telling them about grouping, about adding, and it is telling them about the two sides of the problem. So it's partially correct. So let's see what happens. Here's what this looks like.
Exactly how we practice?
I want to make one side equal to the other side.
Okay.
They did it. They were obedient. Okay. So then all the kids got the same instruction. And I laid it out here because I wanted you to see that we really did try to instruct them. We didn't just let them loose here. We gave them all the answers. No gesture. And before and after each problem, the children had to repeat those words and repeat those words and gestures. Okay. So 3 conditions. And this is what happened. So this is the mean number of problems correct on the post-test. They were 0 before. Before instruction, they all got 0. And the kids who produced the correct gesture were much better than the kids who, or significantly better than the kids who produced partially correct gesture, who were better in turn than the kids who produced no gesture. So the movements they did had an impact on their learning. Yes?
So your scale there talks about 1, 2, 3 kids. So
Right.
is that kind of the numbers that got things correct out of 20? When you
No, it's not out of 20. It's out of 6, actually, which is still not fantastic. Another way to do it, which I often do, and I showed it to you in the first graph, and we'll go back to that later. I often do the proportion of children who succeed, and I ask them to do, usually it's 5 out of 6 to be counted as a learner, and you find exactly the same effects. But you do different kinds of statistics on it if you don't have to use proportions, so we often do it. We use the raw numbers here. But it's a good point, because they're not a huge, but it's not out of 20, it's out of 6. And if you get 3 of them wrong, you can do it by chance. Actually, if you get 4 or 5, it's looking like you pretty much have a good strategy and you know what you're doing. Okay, so what we're thinking here is that the kids are extracting meaning from the hand movements that they made. We taught them a rote movement. Just do it, and they do it mindlessly. But we're thinking that over the course of this study, what happens is that they sort of extract meaning from this and come up with grouping. And they come up with grouping. And the reason we think that that's true is because at the end of the study, in the post-test, we see them produce grouping. And nobody ever said grouping before. So here's a kid. He never said grouping before. He never heard grouping from the teacher. He never saw grouping from her gestures. And here he is.
Because the 6 and this 6, since there's 2 6, I know, so I shouldn't use this one, so I added these 2.
So not only did he get grouping, he's got it. I mean, grouping is all well and good, but you have to know that there are 2 equal atoms there in order to know that grouping goes forward. And he really did get it. And you're much more likely to be like him if you were told to do these correct movements than if you were. Okay. And importantly, during the lesson, as I just said, the experimenter never produced grouping, and the kids only produced grouping in their gestures and never in speech, so it was never said. So we think that this grouping really did come from the kids' own gestures, sort of the gestures that they produced themselves, changing their minds. Okay. So telling the kids how to move their hands changes their minds. Great. But this doesn't scale up all that well. If every time I want to teach a kid a new concept, I have to figure out which gestures to do and then teach the kid the concept or whatever. So we thought, what would happen if we just said to the kids, all right, next time I want you to explain this, gesture. Use your hands when you're explaining it. Just force them to gesture, but don't tell them how. Okay. So that's what we're going to do next. So first we asked kids to solve 6 problems. First, no instruction, just let them rip, do whatever they wanted. Then we divided the kids into 3 groups. One group was told to gesture. Next time I want you to solve these problems, gesture. One group was told not to gesture, and a third group didn't tell them anything at all, just do it again. What this allowed us to do then was to compare the first 6 problems that they solved with the second set of problems in which they were either told to gesture or told not to gesture or whatever. And we can sort of evaluate the change in this. Okay. And what we found here, these are the kids who were told not to gesture, control kids told to gesture, and what we have on the y-axis here is the mean number of strategies that they added that were new, that is, that were different, something that sort of they've never said before. That could be my phone. That would be embarrassing. No, at least it's not. Good. Okay. So, is it my phone? Good. Sorry. Okay. So these are the mean number of strategies that kids never said before. All of a sudden, it's in the second set of problems that they're starting to produce these new strategies. And you find it much more often in the kids who are told to gesture than in control and were told not to gesture. Now, importantly, I have to tell you 2 things about this that's interesting. One is almost all of these new strategies were in gesture. So then you go, well, of course then, the kids who were told not to gesture wouldn't do them. But it is a little surprising that the control kids didn't do them. Also, you could add new strategies in speech. We would have counted that. But very few kids added new strategies in speech. They were almost all in gesture. The other thing that's even more interesting is that almost all of these new strategies were correct. All right, so what's happening here is these kids are answering the problem wrong, giving a wrong explanation in speech, and giving a right explanation in gesture. It's a little like Dr. Strangelove. Where are these new ideas coming from, and why didn't they come out before we told them to gesture? So here, let me give you an example of what this looks like. So here's a kid. He didn't gesture before initially. He was told to gesture. And when he was told to gesture, here he gives a speech, his add all strategy, add up all the numbers in the problem. Okay, so he says, sorry, it's so hard to see.
Okay, be sure to use your hand and show me how you did that one.
7 plus 5 equals 12, plus 4 equals 16, plus 7 equals 20.
Okay.
Okay, so he's saying add up all the numbers, fine. I'm going to play this again, and I'm going to do it without the speech. And I want you to really look at his gestures, because his gestures actually are an add-subtract gesture. What he really does is he points at the 7, the 5, and the 4. But before pointing at the next 7, he does this big pullback. And then he points at the 7, as though to say, subtract 7. They're not all on an equal plane. So this looks like an add-subtract. Okay, so he points at the 7, the 5, the 4, and then pull back, and he points at the other 7. So this really counts. We spent a lot of time coding this very subtle stuff. But this really is an add-subtract strategy. So we've created a mismatcher. We've created one. You know, he says one thing, and he does another. So the next question we wanted to ask is, are these created mismatchers as good as naturally born mismatchers? Are they also ready to learn? So we had to then redo the whole study, redo the study, and then instruct them. After having gotten these mismatchers, gave them instruction to see if that would change their learning. Okay, so we did the study again, and we left out the control group this time. These are the kids who were told to gesture, kids told not to gesture. These kids, as before, they added new strategies to their repertoire. Okay. Then we gave them all instruction. And our question was whether these children, who were now mismatchers, would profit from instruction. Were they ready to learn? And as it turns out, this is the performance on the post-test, and the kids who were told to gesture were more likely to learn than the kids who were told not to gesture. Okay? Now, as it turns out, not every kid who was told to gesture added new strategies. So we divided this group into kids who added new strategies and kids who didn't add new strategies, just to look at their performance. And it turns out that it was the kids who had added new the real mismatchers, the ones who were truly mismatchers, who profited from instruction, which suggests that this is all mediated by the gestures that they produce. Okay? We created mismatchers, and those mismatchers really were ready to learn. Okay, so now we know that telling kids how to move their hands has an effect on their learning. It opens them up to instruction, and then they profit from that instruction. And just telling kids to move their hands, it seems to bring out latent ideas. Once those ideas are up there percolating, that seems to affect, again, how they approach learning, instruction, and it can also change their minds. Okay, so how does gesture change what we know, change our minds? We don't know the answer to this question, so let me just start there. But I'm going to give you a couple of ideas that we've had about the how. So first, gesture engages the motor system, and then I want to ask how what is it about the motor system that affects things. So obviously, when I'm gesturing, my motor system is engaged. That's sort of a no-brainer. But I want to suggest that you, watching me gesture, your motor system is engaged. Even though you're not copying my movements, you're not sort of mimicking me, but implicitly, sort of at an underlying level, you're almost simulating my movements, and that's partly how this whole process goes through. So this is how this is a study we did do with adults. So here's a sentence. We had people hear this sentence. The girl put the towel back in its place. And what the kids were supposed to do, the subjects, U of C undergrads, they were supposed to say, is that object that's pictured there, did you hear that? Was that mentioned in the sentence? It's a picture of a towel. Answer is yes. Okay. If you imagined a towel on a hook, you'd probably be pretty quick to say yes. But if you imagined a towel on a shelf, you'd still say yes. I mean, the answer is yes. You got to do it. But you might be a little slower, just because. And we don't know what you imagined. Who knows? Okay, but that would be just noise. We decided to control that noise with gesture. So we didn't just have them listen to a sentence. We had them listen to a sentence and watch the speaker. Who did this?
The girl put the towel back in its place.
Okay, so she did that. So we're going to bring to your mind this view of towel, and therefore, when you're asked to say whether this picture was mentioned in the sentence, you're going to say yes, and you're going to say yes pretty quickly. You may be a little slower. Again, you should say yes, but you'll be slower for this. In contrast, if you got this.
The girl put the towel back in its place.
Okay. Then you'll be quicker when you see this one, than when you see this one. Okay, so we're just looking for reaction time. How quick you are to respond when you get a congruent picture than when you get an incongruent picture. And the response is the same. It's yes in all cases, and we didn't look at no responses. So here what we see is that this worked. You're quicker to respond when it's a congruent picture. This is reaction time, so slower is worse. And you're slower to respond when it's an incongruent picture. So what this suggests is something that I've been telling you all along. We listen to gesture. We pay attention to gesture. It doesn't tell us that the motor system is involved, but it sets us up to ask a question about whether or not the motor system is involved. Okay? So what we did next is our hypothesis was, as I just said, that listeners activate their own motor systems when they process my gestures, for example. And if that's true, if you load up the motor systems that are involved in gesturing, that should have an impact on how that gesture is processed. So this is how we loaded up the motor system. We had kids in 2 different conditions, and we either asked them to just randomly move their hands or randomly move their feet. Okay? So, and they're doing exactly the same task. They're saying yes when they see the towel and no when they don't. Yes. And this is one of them who was asked to move her. She actually was a particularly delicate one. She really was like a little ballerina. Some of them were a little more prosaic. I'll show you one of those just so you. This is more like what most of them were like. So that's moving your hands. And then moving your feet. Most of them are pretty, they're supposed to be doing different things, but there's only so much you can do. It's a little, okay. So either they move their hands or they move their feet, okay? And as predicted, we expected that if you're moving your hands, the effect should go away. I mean, it shouldn't at some level if you're not simulating the movements. But if you're simulating the movements when you're watching me, and I tell you to move your hands, that could interfere, and it looks like it does, because the whole effect goes away when you're moving your arms. But it's not just moving. It's not just that I'm occupying your mind and your body or whatever. It's the hands particularly, because if you're moving your feet, you have the same effect here. So we see exactly the same congruency effect. If you're moving your legs, they don't interfere, but hand movements does interfere. So what that suggests is that the motor system is involved, not only when I talk, but also when I watch you talk and you gesture. My motor system is involved in all stages in this. Okay, so last point. What is it about the motor system that engages, that leads to change? We had a couple of hypotheses here. One that's pretty obvious, the first one, is that gesture offers a second modality. It's hand in mouth. Excuse me. It's hand in mouth. And this manual modality actually, it's 2 different ways of expressing the same thing, but they're 2 different modalities, and that's what's important. Okay, that's hypothesis 1. The second hypothesis is that, yes, it's hand in mouth, but what's really important is not that it's 2 different modalities, but that those modalities offer 2 different representational formats. Because it's, the mouth is very discrete, categorical, it's speech, but the hand displays things pictorially. It's imagistic. It's analog information. Think about talking about the East Coast of the United States. If I want to really describe the East Coast of the United States in words, it'll be a lot of words. One gesture can do it. Different ways of conveying the same information. So maybe it's that representational format that's really important. Unfortunately, if we're stuck with hearing people who gesture with their hands and speak with their mouths, we can never explore that hypothesis because they're completely confounded. But we can turn to deaf people, deaf signers, to answer this question. Because signers, as it turns out, gesture. This was shown a while ago by Karen Emery. And their gestures are, of course, produced by their hands, which is the same modality in which they produce their signs. The other point is that gesture for signers, just like gestures for speakers, is continuous. Sort of analog, mimetic, all of those kinds of things, and therefore distinct in representational format from sign. So now we're in good shape because we have all within the same modality. We have an analog representational format and a discrete segmented representational format. So we can ask and we can see whether we can find mismatch in sign or whether that predicts learning, which I think is exactly what I have here on the slide. So signers don't use 2 modalities, but they do use these 2 different representational formats. So the interesting question is, do they produce mismatches? What would that mean to produce a mismatch? And I'll show you some examples. And if they do produce mismatches, then does that predict readiness to learn? If it's about hand and mouth, nothing should happen for signers. Right? It should all, because it's not hand and mouth, it's hand in hand. But if it's about representational format 1 and representational format 2, then this all should go through. So that's what I'm testing. All right, so we're going to go back to mathematical equivalence, that math problem. And I'm going to show you a deaf kid. This is a deaf child who's learned American Sign Language from birth. She's a native signer. And she's asked to solve one of these problems. And what she does is she uses the add-all strategy. And she says, and this is quick, this is really fast, so I'll show it to you and then I'll deconstruct it. But she says basically that you add all, and then she goes and she gestures this. And I'll show you. Okay. Okay, so what she does in sign is she produces an add sign, and she produces a sign for all, which is the add all strategy. That's her sign. And in gesture, what she does is first she starts at the 3 and she does this sweep, and then she does bunk, 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 essentially pointing out the 4 numbers that you added. Okay, so she does an add all in both gesture and speech, which is a match. So we looked at the number of times deaf kids produce these things, and we found that actually 80% of all problems, the kids gestured. That's sort of interesting. It's a lot. I don't know if it's a lot or a little, so we decided to evaluate it in relation to what our hearing kids did. So we went to our old data and we found that it's actually not so much. It's about the same as what the hearing kids did. Okay, but now the big question. Can you produce a mismatch when you're gesturing and signing? So here's an example of what we called a mismatch. So this kid actually, in her sign, she signs about adding up the numbers on the left side of the problem and putting them in the right side, putting that sum on the right side. But her gesture is more like an add subtract. So again, here we go. I'll show it to you and I'll deconstruct it. Okay, add and put the number in the blank. So what she does, this is her add sign. It's a sign, but she actually does it on the board, which gives it a gestural quality. But add, put the number in the blank, that's add to equal sign. In her gestures, what she does, first is she indicates the 7, 4, and 2 with this sign, but notice this other hand. She covers up the 7. So in fact, what she's saying is that you add up all the numbers on the left and you subtract this 7. So it's different. There's different information. And nobody would call this cover of the 7 a sign. It just isn't. It's not part of American Sign Language. Okay. So there's different information conveyed in gesture and in sign. All right. So we find, in fact, that about 42% of the deaf kids produce these mismatches, 3 or more mismatches. Is that a lot or a little? Turns out it's pretty much the same as what our hearing kids did. All right, so we can find mismatches, but of course the really crucial question is whether this predicts learning. So what we did to explore this question is first we just arrayed all of the kids as a function of how many mismatches they produced. Some produced none. Happily, we got enough in each category. Some produced 1, 2 mismatches, 3, 4, 5, and so on. And then what we did is we looked at the proportion of children in each group to see how many of them profited from instruction. And in this case, we used as a criterion, you had to get 5 or 6 correct out of 6 in order to be counted as a learner. Okay, and this is what it looks like. The data couldn't look better if I made them up. I mean, they're really terrific. So it suggests that if you produce a lot of mismatches before instruction, you're really likely to learn. If you produce very few mismatches before instruction, you're very unlikely to learn. Okay. Now, how to evaluate that in relation to what I showed you before? Those are the data from the hearing kids. To put it into the same format, the data from the deaf kids look like that. So it's pretty much the same. Okay. It really looks like exactly the same pattern. Okay. So what I've suggested here is that the gesture speech, or what these data suggest, is that gesture speech mismatch predicts learning as well as gesture sign mismatch. That's the crucial part, predicts learning as well as gesture speech mismatch does. And it suggests that it's the juxtaposition of these 2 representational formats. And it's not really about hand and mouth, although that's the alluring sort of possibility. It seems like it may, what's really important is the representational formats afforded by hand, juxtaposed with the format that's afforded by mouth. Okay, so one last bit to summarize and then open up for questions. So what I've tried to convince you is that the gestures we produce provide a window onto our thoughts. That window can be really revealing. First of all, the gestures are not just movements. They really are understandable, in fact, People understand them all the time. You don't have to sit there with a video recorder slowly writing down each gesture in order to understand them. We understand them on the fly. They provide information, and often they provide thoughts. They provide information about thoughts we don't even know we have. Not only do these gestures reflect what we know and provide a nice window, but they can change what we know. We look at other people's gesture and that influences us as much as their words influences us. The way we move our hands can change our minds. So if I move my hand a particular way and I do it often enough, it may influence how I'm thinking about a problem. And finally, the last point is that gesture is in fact an act of the body. It's hand and mouth, for sure. And it may be the fact that it's an act of the body that's really important, but it may not be so important that it's the body, but what may be most important is that the body affords certain kinds of representational formats. And that, in conjunction with what's the format afforded by speech, may be really what gives gesture its power. Okay, so one last video. I want to end with a video since I began with one. All of the gestures that I've been talking about are in the service of communication. They're produced when you talk. They're what we call co-speech gesture. But sometimes we produce gestures without speech, when we're just sort of thinking things through. Those are really interesting. And I want to show you an example of that. This is a kid in India. He has learned to use the abacus. And there's an abacus up there. That's the particular abacus he's learned. So I think you probably all know it's a device for calculating, doing arithmetic additions, subtractions, multiplications, whatever. People get really good at this. Okay, and you use it physically. Here he was given a list of 10 two-digit numbers to recall, to add up. No abacus. He didn't have an abacus on hand. And watch what he does. So 10 two-digit numbers, and he got it right. He got the right answer. So what are they doing? These are gestures. I call them sort of gestures for thinking as opposed to gestures for speaking. They're gestures that are being used clearly to help. Well, not clearly, but it's being used while he's doing mental abacus. We don't know whether it's effective. We don't know whether they serve the same role as all of the gestures that I've been talking about, but that's where we're going to go next. We're trying to explore that. Okay, so let me just end by thanking all of my collaborators and thanking you for listening. And now, if we have any questions, I'm happy to answer them. Yep. Oh, a microphone? Okay.
Have you done any studies cross-cultural? We often think of the Italians that can't even say good morning without their hands, and then you go to Great Britain, and it's almost like their hands are glued in their pockets.
Right. It's a really good question. We haven't done as many cross-cultural studies as I would like, but let me first sort of tell you a little bit about what we know about cross-cultural gesture. Turns out what you say is absolutely true, but it isn't really about the rate of gesturing. What Italians have is a lot of what we call emblems, things like, a thumbs up or an okay, and they have a bunch of them. They have a lot of rude ones that I'm not going to repeat here, more rude ones than we do. But they have a lot of them, and they use them. And that's one of the things that is absolutely true cross-culturally. But in terms of the spontaneous gestures that I've been talking about, people have done these studies looking at Northern Europe and Southern Europe, same rates. But there is a difference. And what Italians do when they gesture is they gesture big. They use their whole bodies. They use the whole system. They're out there in their gestures, so they're much more visible. A Brit or a Swede, much more likely to be down here. But their gesturing makes it much harder on the gesture coder, I have to admit, to be able to code this sort of stuff. So that may make a difference. I mean, it's a really good question. It may make a difference. But we do know that the cross-cultural lore is based not on sort of these spontaneous gestures, but more on the size of the gesture and these emblems. But I would like to do more cross-cultural work because I think it's a good question. I really do. Yep. I guess you get to decide whose question I answer because you have the microphone.
There's a famous parable about Feynman at Caltech that he goes to a club, God knows what, and he's coming home and he's swaying and gesturing like crazy, so a cop stops him. And you may have just explained it. And now my question is, there's a famous story about the Kennedy-Nixon debates. It was always that Kennedy looked better.
Yeah.
Would it, and because if you just played the sound, you got a different result than if you got looking. Was it really the gestures? And have you done any tests with politicians or whomever talking to see whether the video really changes people's minds?
Yeah, that's a great, I mean, I mean, everybody thought it's because Nixon looks gray and he's sweating and everything. But you're right, nobody ever bothered to look at the gestures. And maybe it's the fact that Kennedy was, and typically if you're more animated, you are going to gesture much more. I did think, you know, for Watergate, all of that stuff was on transcript, you know, and it was all written down. People were like, I didn't say that, but maybe they gestured it. You know, maybe they got that information from the gesture. I just thought that it would have been really fun to see videotapes of all, not all of those transcripts, but all of that stuff that went on. So I think it's a great place to look. I myself haven't done work on politicians. I have a colleague, Daniel Casasanto, who's done some very nice work in looking at politicians and whether they use right hand or left hand and how those notions are embodied. So it's a great place to look. It's a really good idea. We should do it. Yeah.
So I really enjoyed your lecture, Professor Goldin-Meadow. I have a comment and a question. The comment is the following. So we are working with ALS sufferers, including Stephen Hawking, to enable them to communicate. And the way we're doing this is we're actually telling them to imagine they can gesture.
Ooh, fantastic.
And we have a monitor on them while they're thinking about gesturing, and we're converting these imagined gestures into speech. And so the technology is there now.
Wow.
So that we can know if SMA, supplemental motor area, which is probably what you're picking up here, is active. So I would encourage you to consider using that kind of technology because we could test people while they're receiving information and when they're producing these things to see if SMA is actually involved. So
right. I think that's a great idea because I would love to instruct people to imagine gesturing. But I've often thought, how do I know if they're telling the truth that they're imagining? I don't know.
So we could do this pretty easily, actually.
Right,
so,
great,
so
okay,
we
should talk.
Part. The question part is, have you found a certain class of individuals, a group of individuals, who might be more susceptible to being fooled or cheated or influenced? So for example, one example that comes to mind would be people who are mute or individuals who have a twin and who have actually communicated by gesturing before being vocal for longer. Have you found any types of people who are more susceptible than others?
It's a really good question. And this field, it's a relatively young field, hasn't explored individual differences pretty much at all. I mean, at all. We don't know whether, I mean, some people think, you know, they're good gestures or big gestures or, you know, even proficient people who gesture a lot. We don't even know that. We just don't know anything about the doers nor about the receivers. But I think the place is wide open for it because we sort of think that there's some people who are really good at gesturing and other people who are not so good. I was just I spent 3 days getting trained by Alan Alda, believe it or not. He's now interested in communicating, making scientists better communicators. So he came to the University of Chicago and he sort of took a whole bunch of us and tried to make us better communicators. And he, now I can't remember where I was going with this. Oh God, what was the? Okay, so he has a bunch of videotapes of people who are good, you know, interviews that he thinks are good, and interviews that he thinks are bad. And what I was suggesting to him is that we take those videotapes, because people do gesture, they gesture on both of them, and start to look at the nature of the gestures to see if we can figure out what makes a good gesture. We don't even know what makes a good gesture. You know, I can give you my hypotheses, but I have no idea really what makes a good gesture. So I think the field is absolutely ripe for all of those questions. And hopefully somebody will go there soon. I'm hoping I can get a student to do that, actually.
I loved your math example because as an elementary teacher, I've suffered through that a zillion times.
Yeah.
And I'm currently doing some proofreading of a math program. And so what I thought of as you did that, well, there were two thoughts. Of course, when I was teaching, I did a lot of stuff with manipulatives to try to help with that. But aside from that, I was just thinking that this application in teacher training would be gigantic because I don't remember seeing a lot of things written about, here's a really helpful gesture, blah, blah, blah. So do you see a big application for that?
I think there's a great application for it in education, and just even encouraging teachers to, in several ways. One is to look at the gestures that the kids produce and to think about them. I bet good teachers do that anyhow.
Yeah.
But not everybody is a great teacher to start, and maybe that could help them to sort of look and process what the kids are doing, because you know a little bit more about what they know from looking at their gestures. So that's one way. You can encourage kids to gesture, because that, I think, will help them. And the third way, perhaps, is to look at their own gestures. It makes me a little nervous to tell people to look at their own gestures, because it could muck things up. I mean, some people are doing just fine, and I'm not sure that if you tell them to look at their gestures, that's a good thing or a bad thing. So I think we have to use it cautiously, but I think there's gesture in the classroom all over the place, and we should just harness it and make it used in the best way possible.
Yeah, and then I also loved your point about not giving two messages, because teachers talk way too much.
But if they do it in hand and mouth, it's okay.
I just wanted to relate this to all the talk about body language.
Yeah.
Because I know that on a lot of these trials that have come up on TV recently, they're looking at the witnesses and the lawyers and what are they doing with their hands and their faces and stuff. And I also remember the switch a couple years ago when you'd hear an executive talk, and they would no longer point when they talked, and you'd start seeing them like trying to point with their wrists, with all their fingers, and stuff like that, where they're trying to train that. And hear stories about people fooling lie detector tests and all that kind of training. And I wonder, how it bundles everything up.
Well, the training, I don't know, these people who train gesture, I'm not so sure what they're training, actually. And some of them, the presidents who are trained in how to gesture, it can look so false and phony. And it can be more distracting than it's good.
So can the executives.
I completely agree. Some people just sort of soak it up and it becomes natural, and others look like, well, somebody told me this gesture with a word that's important, so I gesture, and it looks terrible. So that's why I worry a little bit about telling teachers to monitor their own gestures. I honestly think if you get the words right, if you know what you're talking about, the gestures will come for free. So we have to teach them to know what they're talking about more than, that may be harder than teaching them to gesture. But you can get people to up the rate of gesturing, and that could be useful. It could be. I think we have to think about that and see, do the studies to see if it's true.
I'm still bothered by the fact that you gestured East Coast, and that isn't what we saw.
You didn't see East Coast? No? You didn't see the May? Oh, it was a bad gesture? No. Oh, it's backwards for you, of course, right. Sorry about that. Sorry about that. You're absolutely right. So some gestures may be more effective than others. Totally, really egocentric, but I could do it the other way. That's better, isn't it? That's much better. Good point. All right, in the future, East Coast like this, absolutely. All right.
I got the impression from the talk that that gesturing might have something to do with like acquiring new ideas, and I was wondering if any interest or thought had gone in the direction of like animals learning with gestures, whereas they just completely lack a speech channel to
yeah,
learn within.
that's an interesting question. I had a student. So one of my former students, Erica Cartmel, who's just actually moved to UCLA in a position, has been studying gesture in chimpanzees and other, great apes. And they sort of gesture. I mean, they do little things. They can occasionally point. They do these little give things. Sometimes they'll rub you, say they want you to touch them here or scratch them there. But what they never seem to do is to use it in a representational way. And they're our closest, friends and relations. So I don't know whether we can get any other animal to gesture in the same way. Now, I guess it depends on partly what you mean by a gesture. There are birds who do their little wing flaps, and that seems to, it works for the other bird. So, the female bird flaps and then he sings in a different way. That could be called a gesture. So I think there's potential there to think about it. But I don't think they're using it in quite the same representational way that we use it, which is, we're holding on to that as being somewhat unique to humans.
I was thinking like in the way that birds sometimes will grab twigs and then they'll do novel.
Yeah, well, birds are really smart. They're really smart. In fact, there's in a couple of weeks at the beginning of November, I'm coming back to San Diego to give a talk to a bunch of people who do research on bird song, because they're sort of interested in gestures. So we may be able to develop some hypotheses there about the way in which it might help birds live.
When we try to help kids improve their reading comprehension, we teach them to visualize. Have you done any work with gestures and visualization?
We haven't done it per se, but at some level it's fundamental. It's what we're thinking. It's all about visualization. At some level, and it's really hard to measure visualization. There are some tests. This gets back to this issue of individual differences. There are some tests of whether people are a good visualizer or a bad visualizer. We've never gotten those tests to predict anything in our gesture data. But of course, the tests could be bad. We may not have the best tests of visualization. But I think that's fundamental. It sort of underlies all of this. We just don't know how to get at it in a great way yet.
And then I have a second question. I think I heard you say that when people make random gestures, that their understanding decreases. Is that correct?
Well, I'm not sure what a random gesture is.
The girls in front of the monitors making either movements with their feet or
Oh,
their
I
hands.
see. Well, their understanding didn't change. It's a good point. What happened is that they were slower to respond to this ridiculous question that we asked them, like, their accuracy didn't change, but their rate of response changed.
Because there's something we always wonder about in the classroom, which is when kids fiddle.
Yeah.
Is that good or bad?
Yeah. It's a good question. We don't know so much about whether fiddling counts as a gesture. It's certainly moving. We've done some studies where we've looked at sort of whether gesture lightens your cognitive load, and these are all of these studies where we've prevented people from gesturing. But when you prevent somebody from gesture, they start fiddling like crazy. The fiddling actually didn't have the same effect as the gesturing in that context, but it might in other contexts. I think the other thing to ask about the blind, the blind speakers often, I gotta put this down, I can't do it. They move their hands a lot. Not every blind person, but many congenitally blind people are like constantly moving their hands. That's sort of ultimate fiddling. We don't know what function that serves at all. I think it's a good question. We need to ask about, I sort of believe that this representational force is what's important about gesture, but there's sort of something about just moving that may also be part of it. And then on top of that, we have this representational edge to gesture.
So in connection with your representational perspective, does making faces count as gesture?
Ooh, good question. Yeah. So I have never looked at the face because I got enough to do coding the hands, frankly, and that's really why I haven't. But a new postdoc just came to the University of Chicago, and she is a researcher in the face. And so she's interested in seeing, when you listen to when you watch an emotional movie, you just lay it out on your face. And she's interested in seeing whether you take those facial movements when you're then talking about the movie. Do you reenact those facial movements to see whether it becomes communicative? So I don't know, but it certainly counts as a gesture in the gesture world. But I don't know whether it functions in the same way that the hand does. And we'll soon know, I hope. But the face is much more, it gives you much more information about affect, sort of how I feel about things, my emotion, whether I like you, whether I don't like you, whether I like what I'm saying, that stuff. Whereas the hands can convey more substantive information. We don't really convey, the strategy of add to equal in our faces. But we do convey information, and I think it's important. So soon.
The children in your videos are old enough to have been in that cadre of children who may have been taught signing early on.
Yeah.
Is there any history that you have on the effect of signing and learning later on?
That's an interesting question. We certainly don't know the history of these kids, so we haven't looked. I have another half of my life where I look at little young children acquiring language, and I've looked at their early gestures. The early gestures that children produce are important. They also, in some ways, you can find little mismatches in baby gestures. So for example, if a kid points at a bottle and says mommy, because it's mommy's bottle, she doesn't mean that that's mommy, she means it's mommy's bottle. That's almost, it's a little mismatch in that the gesture and speech are conveying different information. You put that together and it makes a sentence. When kids do that, 3 months later they're going to start producing 2-word sentences. Now that's not about the baby sign stuff that's being taught. That's really about spontaneous gesture. The baby sign stuff is it's controversial. I think that what people believe is that it doesn't hurt, but it may not help. There's not great evidence that teaching these kids gestures helps to even get them to learn words faster. But it doesn't get in the way, and it might make mother-child interaction better. I mean, it may, or father-child too. It may just make the whole situation easier because I can say what I want as a kid. But it's not clear that it even has an effect on language learning, let alone on math learning. But who knows? You know, there's a whole generation out there. We could explore it and see.
You began the talk with a slide about negotiating. The topic was negotiating.
Yeah.
We had a discussion recently about competence of negotiating. And have you done any work, probably not because you're more educational, have you done any work dealing with gesturing and facility of negotiating?
Yeah, I have a student now, Steve Jacobs, who's interested in gesture in the law and in the court. So I think eventually he'll get there. But right now what he's doing is he's interested in looking at whether or not you have gesture in your closing statement. And is that persuasive? Are you more persuaded when that closing statement has a gesture or doesn't have a gesture? So I think that's his first step at looking at gesture in legal situations. But my guess is that eventually he'll get to that question, because it's a very good question to ask about how that affects, you know, negotiation. Certainly body language must, you know, things that I haven't looked at all, whether you're smiling, whether you're hunching over, whether you're just like that must affect negotiations. But we haven't looked at all. It's a good place to look at.
Second question is methodology.
Mm-hmm.
How do you analyze all this data that you get? I assume after the people looking at the
That's how we do it. It is unbelievably time-consuming. So there are, you know, for face stuff these days, there's a system called fax. Done by hand is really hard. It's the facial action coding system. But they now are developing machines to sort of code the face quickly and do all of that. I can't figure out how to do that for gesture, because the same movement could look quite different. If I'm gesturing this to mean up, if I do it like this, if I do it like this, if I do just this, all of that still means up. So it's going to be really hard to know which physical forms are going to be used in the same way. So methodologically what we do is we code the gestures, we write them down, we code the speech. One of the things we do, and in fact this led to the discovery of the whole mismatch phenomenon, we code them separately. First we spent a long time just learning about what kinds of speech strategies are produced in a context, what kinds of gesture strategies are produced, and we get sort of a lexicon for speech and for gesture. But then what we do is we code speech separately, you know, with just the audio on, no video, and gesture with the video on and no audio. And the first time we discovered a mismatch is when Brecky Church, whose work this was, she went and she coded it and she found all of this stuff, and then I said, you know, let's make sure we're doing this right. Code it separately, code gesture separately, or speech separately from gesture. And she did that, and she said, I'm getting different things. You know, I'm finding out it is not always the same. We didn't notice, because I think we as listeners, or as researchers, integrated it so quickly and so naturally that we didn't see it until we separated it. So methodologically, that's really important for us to say, okay, code it this way, code it separately, and then put it together. Because if we code it at the same time, you can't see the fact that it's different information. Our brains just like to integrate it. So it's a good question.
So we have time for one more question.
Okay.
Hi. Are there any studies done on the way that people gesture differently if they are suffering from any particular disorder such as schizophrenia or, say, depression or bipolar?
Yeah, I have not looked at schizophrenics. I think it'd be really interesting to look at schizophrenia. One of David McNeil's students did look at schizophrenics and did find some differences. It's hard to sort of say. There were some differences for sure. We have looked at brain injured children who have unilateral focal brain injury, and they, of course, they don't gesture with the hand that they have no control over, but they gesture with the other hand. And sometimes even if they're doing something with this hand, they'll even gesture with this hand. So gesturing is really pretty important. So you gesture even if it's not something that, even if it's hard to do. Autistic children are said to gesture much less. And I'm doing a study with a colleague which suggests that that's really true. They just gesture much less. Now, who knows why? One might say about autistic kids, well, the social issues are so weird, and they are socially, that's one of their problems. So maybe it's just about social interaction. But we've also looked at Williams syndrome kids, not formally, informally, who are intellectually impaired but very social. They don't gesture. I mean, I can't swear to that. We just did a cursory look at the videotape, but it's intriguing that they didn't gesture. So I think it is of interest to look in these situations. And we have I'll just say one last thing where I think gesture can be really helpful for diagnostic purposes. So we've looked at brain injured kids at 18 months, and these kids were at the floor for speech. They were way at the bottom, in fact, out of the range of normal for these kids in their speech. But if you looked at the gestures, some of them sort of gestured within normal range, and others didn't. That's at 18 months. We then looked at progress over time to 30 months, and you see that the kids who had gestured within normal range gestured within normal range, but their speech was out of normal range. Their speech improved, and they ended up in normal range. The kids whose gesture was down here, as was their speech, stayed at the bottom. So that's really important, I think, because you want to know which kids, not every child who has brain injury is going to be at risk for language delay. And it would be nice to know which ones need really the attention. So by looking at gesture, we could predict which kids were just going to, on their own, get into the normal range and which kids would not. So I think it does have a use. It has some potential to be used for diagnosis and maybe even for remediation. That would be the second part.